Hey guys, welcome to Theorems and Friends. I am Mabilangan, your host for this video tutorial. Today, before we start, we have three objectives, which will be discussed by Sacdalan.
So here is Sacdalan. He's
Hi.
going to discuss the three objectives. So I'll leave now.
So first, before I start, can I have a chair? Oh, thanks. The first objective is like we would help you determine what the graph could possibly look like using far left and far right. The second objective is to find out if there is a root in between two intervals in the continuous function. Help you solve a binomial expression that has been raised very largely. Back to you, Ono.
Back. Thank you, Sacdalan, for that wonderful objectives. Okay, so we're going to talk about our first topic, which is the far left and the far right theorem, which will be discussed by our friend Cassandra Zulueta.
The far left and the far right theorem. This helps us determine the end behavior of the graph. Here we have a polynomial function. In order to determine the end behavior of the graph, we must look at the leading term. Here, a is the leading coefficient while n is the degree. Here are the cases. If n is even and a is positive, then it will go up in the far left and up in the far right. If n is even and a is negative, it will both go down in the far left and far right. If n is odd and a is positive, then it will go down in the far left and up in the far right. While if n is odd and a is negative, it will go up in the far left and down in the far right. Now let's try this. Given the function f of x equals 2x cubed plus x minus 1, determine what the graph could possibly look like. First, we have to look at the leading term, which is 2x cubed. Here, the leading coefficient is positive, which is 2, and the exponent is odd, which is the degree of. Now, let's recall. Now that we know that, therefore, the graph would look like this. It will go down in the far left and up in
Back to you, Ono.
The next topic to be discussed is the intermediate value theorem. It will be discussed by our friend Tyler Reyes.
The intermediate value theorem. The intermediate value theorem lets us check if there is a value between the given interval. The theorem states that if a continuous function f with an interval of a and b as its domain takes value that f of a and f of b at each end of their interval, then it also takes any value between f of a and f of b at some point within the interval, with the points between a and b. Therefore, there must be a root between them. Let's solve. Use the intermediate value theorem to show that f of x is a continuous function. F of x is equal to x cubed plus 2x minus 1 has a root on the interval 0 and 2. So we have to substitute the values of the intervals to the equation. And in this case, we have 2 and 11 as the answers, which means that there is a root between 0 and 2.
Our last theorem, which
Back
is
to
the
you, Ono.
binomial theorem. It will be discussed by our friend earlier, Zulueta.
the binomial theorem. A theorem that gives a way to expand the binomial in a specific pattern. The binomial theorem is a quick way of expanding binomial expressions that has been raised to a large power. There are different ways to expand the binomial, but we're going to focus on the Pascal's triangle. The binomial theorem, or binomial expansion, describes the algebraic expansion of powers of a binomial. Using the binomial theorem, let's try and solve a plus b raised to the fourth power. But first, what is the Pascal's triangle? Basically, it is a pattern where you start with 1 at the top, then continue placing numbers below it in a triangular pattern. Each number is the numbers directly above it added together. As we can see, the coefficient of the expression is 4. So with the corresponding value, we count down the pyramid by 1, thus we get 1, 4, 6, 4, 1, which are the coefficients. Now, once we have the coefficients, we have to write them down, and using a and b, the exponent of the first term, which is a, will decrease, while the exponent of the second term, which is b, will increase. Now, to get the final answer, all you have to do is to simplify. Which then, here we have the final answer. A raised to the 4th power plus 4a raised to the 3rd power. Now, here's a recap. The binomial theorem. This gives us a quick and easy way to expound binomial equation raised to a certain number. This uses the Pascal's triangle for the format, and it is a plug-and-chug system.
Okay, back to you, Ono.
These theorems gives us the quickest way to solve things and to properly graph. To sum it all up, the binomial theorem helps us to solve the binomial expression with ease, especially with the Pascal's triangle. The far left and the far right theorem can help us determine what the graph could possibly look like and the possible end behavior it could have. The intermediate theorem helps us to draw continuous functions with the help of roots between the function. The binomial theorem helps us to solve the binomial expression with large powers with ease and quickly with the use of Pascal's triangle.